So the mean value theorem is a theorem that revolves around derivatives. Okay? So I'm going to show you. This picture up here is just to show you what the mean value theorem is. Okay. So let's say that the first black dot, that's at 0, 0, represents our starting point. Let's say the second black dot, which is like about at 4.7-ish, right, is our ending point. Let's say this is our interval. Let's say this guy is our interval right here. So the green line, it's not green on your paper, but the green line represents a secant line. It's not a tangent line. It's not a tangent line. It's a secant line. Secant line means when it cuts through. Tangent line means when it ricochets, kind of, touches in one spot. So if I were to find, so what the mean value theorem says is, if I were to find the slope from beginning to end, dot to dot, right? Find that slope. So that slope is going to be I'm just going to approximate it here. It looks like I go down a unit and then go over 4.7 units. So this would be about negative 4.7 over 1, right? Positive. No, negative, you're right. I'm right. That's around the slope, right, of the secant line. So what the mean value theorem says is somewhere between those two dots, I had to have had the same slope as the green line. If your slope from beginning to end is whatever it is, somewhere along the way, in between black dot and black dot, I had to have had the same exact slope. Somewhere. More than likely, it's probably going to be somewhere around here. Probably somewhere around here, because those two lines are parallel. The green line and then the red line I just created, they're parallel. So that means they have the same slope, right? So as long as it's continuous and differentiable over that interval, I'm going to have the same slope. The mean value theorem is probably the one that is most, out of all of these theorems, is most applicable to real life. And I'll explain how. Okay, so derivative is slope. What is slope, though? Slope is what? It's rise over run. And what is rise over run? Rise over run is starts with an R. Ratio, it's a rate, right? It's a rate. What is the most common rate that you guys deal with in your life? You guys are all above 16 or older. I think all of you guys are 16 or older. What's the most common ratio that you guys deal with on a day-to-day basis? Those of you that driving, right? Most of you guys at least have a license or are driving or learning to drive, right? So if I'm a driver, what's the most common ratio that you deal with? Miles per hour, right? You always see it. When you're in a car, you always see miles per hour. How fast are you going, right? So you look down at your wherever your speedometer is, and you're going 45 miles an hour, 35 miles an hour, 26 miles an hour, right? That's instantaneous because that's at one second. At one time you're looking, right? So what the mean value theorem says is over the course of your trip. So over the course of your trip, let's say you go from here to, I don't know, you're driving somewhere. Let's say you go from here to River Park. So you're driving from here to River Park. And it takes you, I don't know how many, it takes you this many minutes over this much time. So over the course of your trip, right, it took you, so let's see, or let's do a longer trip. Let's do a trip to like Los Angeles. Let's say you were going to LA. LA is roughly 250 miles away, right? Let's say you got there in 4 hours. From beginning to end. From beginning to end, you got there in 4 hours. Got in your car, got out of your car in 4 hours, right? And it's about 250 miles, right? Your average rate is what? How would I find average rate? Divide, right? You would divide. You would say 250 divided by 2. Or divided by 4, sorry. 62 and a half miles. 62 and a half miles. So you were going, on average, 62 and a half miles per hour. Okay? That's miles per hour. That's average, right? Let's say someone else drove a week before, the same 250, but they got there in 3 hours. What was their rate of change? Let's see. Divided by 3 now. 83.3. On California highways, what is the most of the time? What is the maximum speed limit you can go on California highways? 70 is probably the highest. I've never seen anything above 70 posted, right? 65 in the town. So if you're in a town, 65. When you're out of the town, so when you're traveling between towns, it's usually up to 70, right? This person here, did they break the law? Yes. How do you know? You didn't see them. Did you see them drive the car? Did you have a radar gun to do like cops do when they have radar guns and they're radaring you? How do you know they broke the law then? How do you know though? How do you know they were driving above the speed limit? Because you weren't in the car. By their rate of change, which is also called what? Slope. By their beginning to end slope, I know they had to have broken the law at least once. That's mean value theorem. Did you guys just figure it out? The reason you guys said they broke the law is because of the mean value theorem, right? Somewhere along the trip, they had to have been going 83.3 or more, right? It's an average, right? So if your average is this, somewhere along the line, I don't have to be in the car with you. I don't have to have a radar gun on you, but I know that you had to have broken the law somewhere. You had to have gone over 70. That's what the mean value theorem says. So this is what cops used to do. Cops used to be on the highway, except they wouldn't have radar guns. They would just be sitting waiting. So you drive by and they're just sitting there on the side of the road. And they would radio down to someone down the road, a few miles down the road. And they would say, okay, this car with this license plate got past me at this time. And then down the road, they would time them and see how fast they got to them. So if they got to them at a rate over 70 miles an hour, ticket, boom. It's called a speed trap. It's called the speed trap. They didn't have a gun on you. They didn't have not a radar gun. They didn't have a radar gun. They didn't see you speed because you were speeding in between from beginning to end. They didn't see you speed, right? So, but through the mean value theorem, if you got there, so if you got here, if you got from here to here in this amount of time or less, you had to have been breaking the law somewhere along the line to give you a ticket. They said you were going over the speed limit, even though they didn't see you do it. Okay? If you got there in less time, like it took you more time to get there, then they know, okay, then they were, their average speed, that's okay. They average that. That's not against the law. They average this, that's against the law. Okay? It's called a speed trap. It's called a speed trap. Some places still do it. I don't know if California still does it. They don't really tell you if they still do it or not. But that's one of the speed traps. It's one of the things. Have you ever heard of something called a speed trap? That's what it is. That's what it is. Because They kind of trap you into thinking, oh, because when you cross the first police officer, you're not speeding. When you cross the second police officer, you're not speeding, but in between you were speeding, right? So they're able to track your rate. How fast did I get here? Well, they had to have been going above the speed limit. So they used calculus to actually give you a ticket. Okay? That's the most applicable, that's the best example of this in real life. That's the best example of this in real life. So my caution to you guys is when you're driving on the highway and you see a cop and you slow down, don't assume that it's over, right? Because sometimes they will do this and that's how they'll get people people without even knowing, because they're not, or a lot of people have radar detectors, right? Well, if you're not using it, it doesn't pick it up. So if you see a cop on the side and they're not using their radar, it won't pick it up. So they won't give you a ticket there, but at the second one, they might be using, some app where they can track the time and stuff like that. Okay. So that's, like I said, that's a speed trap. That's the most applicable way in our life how we use it. That's the best way I can explain it. It kind of makes sense to you guys, especially because you guys are drivers. You guys are at that age, right? So even though I didn't see this person speed, I didn't actually see them speed, I know they had to have been going fast because of mean value theorem. Okay? So that's essentially what the mean value theorem is. Okay. So how do we do that? Well, we need two things. To do the mean value theorem, we need two things. Well, first of all, this has to be true. It has to be continuous. So if I'm in my car, I can't go stop by the side of the road and stop, right? It has to be continuous. It has to be differentiable, right? So as long as it's continuous and differentiable, there has to at least exist one point where this is true. Okay, so the one on the right, what does this look like? You guys have seen this many times. What does this look like? Formula for what? This guy right here. What does this represent? Subtraction on top over subtraction on the bottom divided. Something we just talked about. The formula for slope. This is the formula for slope. y2 minus y1 over x2 minus x1. So this is average rate of change. Slope from beginning to end, from the start to the end. Okay, that's what that is. So you find the rise over run from beginning to end, right? y2 minus y1 over x2 minus x1. That's what it is, okay? The other side, this guy you've seen a lot of too. What are we going to do here? What are we going to do for this guy over here? Not continuity. Find the derivative and figure out where C is. Yeah. Apply the derivative. That's more than what we were doing. Wherever they equal each other is your answer. Wherever they equal each other is your answer. Okay? So we have to do two things. Find the derivative and find the average rate of change, set them equal to each other. When we do that, we got our answer. Okay? So apply the mean value theorem on the indicated interval. In each case, make sure the hypothesis is true. What I mean by hypothesis is true is make sure there's no numbers I can plug in that would make it discontinuous. Is there any number I can plug into f of x that I wouldn't get a number out? I'd get undefined? No. How do I know? How do I know if there would be a number I could plug in for x and I would get undefined in my calculator? Has to be a denominator, right? There is no denominator for that guy. So it's a continuous. Okay. Okay, so that's f of x. Our interval is from -1 to +1. I drew the picture over here just to kind of give you an idea. They won't give you a picture most of the time, but for the first example, I wanted to give you a picture to see what we're looking at. So this is f of x. This is the graph. Okay? So our interval is from -1 to +1. So -1 is here. +1 is right here. So the first thing we have to do is find the slope of this line that connects black dot to black dot. Now, 99.9% of the time, they won't give you a picture. So let's pretend that picture doesn't exist. Let's pretend that we only have this info here. How would we find slope from black dot to black dot without the picture? Not the derivative. We don't need to use the derivative. Average rate of change. So when you find a slope, what do you need to find a slope? So like when you found slope back in 7th grade for the first time, what were the things that you needed if you didn't have a picture? 2 points, right? We need 2 points. I need 2 x's and 2 y's. I have 2 x's, don't I? What's the first x? What's the x for the... Don't I know the x's for those 2 black dots? All right. So y1 is -1. x1, or sorry, y2 is +1. And we subtract them, right? So really you're going to add them because you're adding a negative. How do I get the y? So how do I get the y value for +1 or for -1? Yeah, make a little table here. X, f of x. I know +1 and -1 are going to be my points. I have to get the y with it. So I'm going to plug in +1 first. So 1 times 1 squared minus 1 minus 2. So that's 1 times -2. Double check my math to make sure I did that right. We have the picture to verify, but usually we won't, so I don't want to really rely on that. So 1 -2. That looks right. So that's the y coordinate for -1. Thanks. Now I'm going to do the same thing for 1. Plug in a 1. -1, sorry. Minus a -1 minus 2. So let's see, this one is -1, and then 1 plus 1 minus 2. So that's 0, so it looks like it's going to be 0. And yeah, -1, 0. So the 2 points I have are 1 comma -2 and -1 comma 0. So when I do slope, I get -2 over +2, which equals -1. That's the blue guy. So I have the blue guy. How do I get the red guy? What do I need to do to get the red guy? So I got the blue guy. That's -1. How do I get the red guy? Don't worry about the C. If the C's throwing you off, don't worry about that. Find the derivative. Find the derivative. I haven't done that yet. The derivative of f of x, right? Well, this is the original, right? Instead of using product property, or sorry, instead of using, the product rule, let me just distribute, because then I can just use the power rule. So it's going to be x to the third minus x squared minus 2x. Now derivative. 3x squared minus 2x minus 2. So this is the blue guy. This is the red guy. What do I got? What's the last step? What do I got to do with them? Set them equal to each other. Set them equal to each other. 3x squared minus 2x minus 2 equals -1. And then you're going to do what you did in Math 2 and Math 3. Solve for x. So first thing I need to do, all the steps, like I said, I happen to be doing this exact thing in Math 3. So the steps right there, set it equal to 0. Add 1 to both sides. 3x squared minus 2x minus 1 equals 0. GCF, no. Leading term is positive. Let's see, so A is 3, B is -2, C is -2. -6, -2. What's up? -1, you're right, yeah. So this is going to be -3. So the two numbers that multiply to be -3 and add to be -2. Let's see, 3 and 1, -3. So I get 3x squared minus 1 minus 3x plus 1x. Like I said, this is how I teach my Math 3 students. However you learned in Math 2 or Math 3, do that to factor. Okay, so if this process isn't making any sense, that's just the way, like I said, each Math 2 and Math 3 teacher teach their own way to factor. So if you know a better way of factoring, use it. But this is the way, like I said, I teach Math 3. When I teach Math 3, this is the way I teach them how to factor. So this is going to be 3x, 1x, minus 1, and plus 1. So you're going to get 3x plus 1, x minus 1 equals 0. So that's factored. Set them both, set all the factored terms equal to 0. So I have this guy here, and solve for x. -1. So I get -1/3. And +1. Okay. So what do those numbers mean? Those are the C terms. Saw C up here? Those are the C terms that make it true. Those are the guys that make both of those equal. And I'll show you why. That's one of the reasons why I did a picture. So let's go figure out where x equals positive 1. Where does x equal positive 1? Right there. It's barely inside the interval, but it is. If I were to find slope of the tangent line here, wouldn't that have the same slope as the green line? Where's 1/3? Negative 1/3, sorry. Negative 1/3. Negative 1/3 is right about here. The slope of that tangent line is the same slope as the green line. Those are the 2 points between black dots that have the same exact slope as that green line. That's where I was going 83.3 miles an hour, 62.5 miles an hour. Those are the 2 spots where you equal the average rate of change from beginning to end. Okay? That's the mean value theorem. That's what the mean value theorem says. So when we find those points, what does it mean? It means it has the same slope as your average rate of change overall, right? It's the spots where I was going. Where on the trip were you going exactly 63.2 miles or 62.5 miles an hour? That's what we just found. Where was the spots I was going when I crossed this place, when I crossed this place? Where on the trip was this person going 83.3 miles an hour? Well, they were here, there, here. That's what I just found. Exactly the locations. Okay, I pinpointed the locations on where they were going that speed. Okay, and that's what the mean value theorem says. Okay, all right, so let's look at the next one. Let's look at number 2. Same question. So anytime you see apply the mean value theorem, don't let all of the other stuff kind of ruin or affect your reasoning. We do the same thing every time. Find the average rate of change from beginning to end. Find the derivative, set it equal to each other, solve, you're done. Okay? So it says apply the mean value theorem to the indicated interval. So the interval goes from -3 to 5. In each case, make sure the hypothesis is true. So we have to make sure the hypothesis is true. There were 2 conditions. Is it continuous everywhere within the interval? Check right now. Is it continuous everywhere within the interval? Where is this guy not going to be continuous? Positive 1. Is positive 1 inside of the interval? Yes. So we can't do this problem because the mean value theorem does not apply. Because f of x is not continuous at x equals 1. It's not continuous at x equals 1. So I can't even go any further. Here's the scary part. Not scary part, but kind of different. If you were to do this problem, let's say you didn't even check, and you were to do this problem, find the slope from beginning to end, find the derivative of f of x, set them equal to each other. You know what? You would have gotten an answer. You would have absolutely 100% gotten an answer. But that answer would have been for nothing because it doesn't apply. It doesn't apply. So that's the first thing. You always want to check to see if it applies. When will it not apply? Two times. When it has a denominator or it has a root, because those are the times we get undefined, right? Those are the times. If you get a root and you have a negative under the root, that's imaginary. That doesn't exist. or you have a denominator. Okay? I've seen students do this problem. I used to have this problem on one of the homework assignments, and students would get an answer. I got an answer. And they did all their math correct, but they forgot to check the beginning, to check to see if the hypothesis is true. Is it true? It's not true. So any answer you get is worthless. Okay, so make sure you always check. That's why I put this question in the notes from now on, because I want you to check it. Okay, okay, so let's go to example number 3 now. Okay, so function f of x is graph below. So they don't have the graph, but so the interval goes from -6 to -3. So the interval goes from -6 to -3. Is there any number I can plug in for x that would give me undefined in f of x? No. Doesn't have a root, doesn't have a denominator. I'm good. Okay, so I can continue going. Okay, so the first thing you got to do, find average rate of change. Let's find the average rate of change. Average rate of change. So -6 comma something is going to be the first dot. -3 comma something is going to be the second dot. Okay? So we're going to go -3 minus -6, because that's y2 and y, or x2 and x1. Now I have to figure out the y values that go with that. So -3, -6. -3 cubed plus 7, -3 squared plus 4 times -3 minus 17. And then the next one is -6 cubed plus 7 times -6 squared plus 4 times -6 minus 17. Okay. That's not hard math, but it's a little tedious. So let me look at my notes to see what the answers are. So to figure those out, you would just cube -3, which would be -27. Then -3 squared is 9 times 7 is 63. You would add them together and then subtract 12 and then subtract 17. So it's nothing you can't do. But like I said, for time purposes, let me jump ahead. Okay, so here we go. We got, so when we plug in when I plug in, what did I get? -3. When I plugged in -3, I got -7. When I plugged in -6, I got -5. So those are the two dots, -3 comma -7 and -6 comma -5. So -5 goes with -6. -3 goes with -7. Subtract. Subtract a negative, you get -2 over +3. -2/3. No, you don't. Wait, what did I do wrong? 5. Oh, sorry, yeah, positive 7. Sorry. This is supposed to be positive 7. So it's positive 12 over 3, which is equal to 4. Okay? That's the first part. Second part, derivative. Three x squared plus 14x plus 4. That's the second part. Set them equal to each other and solve. Solve for x. Subtract 4 from both sides. 14x. Yep. So you get 3x squared plus 14x equals 0. It's a binomial, so you can factor out a GCF. GCF is going to be just regular x. So 3x plus 14. Set x equal to 0. Set 3x plus 14 equal to 0. Divide by 3. You get x equals negative 14/3. Here's a question now. I got 2 answers. What is... So here we go. Let me phrase it to you as a multiple choice question. Are my answers 0 and negative 14/3? 0, negative 14/3, or none? Why C? 0 is not in the interval. So 0 will have a slope of 4, but I don't care because it's not in the interval. So C is my answer because that's the one in the interval. So 0 works, but I don't care because it's not in the interval. Okay. All right. Okay, so what do we have? A couple more things, and then we have one more problem like this, and then we have some graphs. We haven't really looked at any graphs. I'm going to show you some graph stuff, and then we'll be done. Okay. So tomorrow we'll finish.